Oh, I get frightened. I see unable to do live. I get. All right, nice. So we're gonna take a look at applications of differentiation. Anybody remember any applications? To find the gradient function or the gradient tangent. Nice. What's the next one? Right, is using rates of change. And one more. Maximum, minimum, right? Yeah, to find stationary point something. Good. So the first one is used to determine the gradient function. Right. Second thing it's used for is to determine maximum, minimum points. Right. And third thing they use them. Well, there are some other things too, but for you, these are the three things I have to do. Rates of change. Oh, wait, one more. Wait, how did I forget that? One more. There's one more thing that we use the differentiation in. Kinematics. Right? We use it in kinematics. Okay. So we're going to start with the gradient, determining the gradient function, right? So within your number 4, which is differentiation, they will ask you to differentiate something like this. Then they would ask you two of these rules. One is kinematics and one is number 1, 2, or 3. All right. So that's what the number 4 will look like. I think it's 4 or 5. One of those numbers. Nice. Finish. All right. So we're going to take a look at finding the gradient function, right? Right. Let's say I gave you a function looking like that. That function is a curve, right? So at different points, the gradient always changing. So let us say this function is y is equal to f of x. At different points, that gradient is always changing. So we need to find a way to get the gradient at any single point. Okay? To get the gradient at any point, here's what we could do. Right? To get the gradient, what we could do is we could differentiate f of x. Right? And this gives the gradient function. I'll give you the gradient function, right? Second thing you're going to do, we're going to substitute, right? Right here has an x value. You're going to substitute the x value. Substitute the x value at that point. And obtain the gradient of tangent. So when you substitute the x value, oh, by the way, substitute the x value in dy dx, right? substitute in the gradient function, you will get that tangent, right? Let me just try and draw it here for you. Right, that there's your tangent. So whenever you differentiate and plug in the x value, what you're really finding is the gradient of tangent. Anybody remembers how to get a gradient of the normal? Right? Anybody remember how to get a gradient of the normal? The normal is this line here. Perpendicular. How do we get the gradient of the normal? Multiply by close to it. Negative reciprocal, right? Negative reciprocal of the gradient of tangent. Okay. Just one more thing to remember. Well, I really hope you remember this. Equation of a line. How you find it again? Right, y is mx plus c, or you use y minus y1 is m by x minus x1, right? Let's make a little note of that, because these questions come in that particular form, right? Minus 1 over the gradient tangent. Negative reciprocal, right? Flip it over, change the sign. Yeah, finish. All right, so let's start with one here. Let's start with example number 1. All right, Emily writing online, nice. Okay, good. Right, let's see if we could find the equation. Find the equation of the tangent at 2, 1. On the function y is equal to 5x squared minus 2x plus 1. Right? So you want to get the equation of tangent at that particular point. All right? I'm just doing a quick sketch. I don't know if the quadratic right, I'm just making up something. It might look something like that, right? What they're asking for is at a particular point, let's say here's 2, and here's 1. At this point here, they want the, hold on, I'll make it look a little nicer. Right? At right. At this particular point here, what they would like is they would like the tangent at that point. Okay? So to find the tangent, right? To find tangent, what do we need? To find the equation of tangent, we need 2 things, right? We need number 1, gradient, and number 2, point on the line. So how are we going to get a gradient? We have to differentiate. So y is equal to 5x squared minus 2x plus 1. So dy dx is how much there? 10x minus 2. Right. How do we get the gradient of the tangent? How do we get the gradient of the tangent? All we have to do is substitute the x value, right? X is what? Right? X is 2. So therefore, the gradient will be 10 by 2 minus 2. 20 minus 2 is 18. Right? This function here is called a gradient function. So by just putting your x values in, you'll be able to find the gradient. So we know the gradient, we know the point, so we know m is 18, we know x is 2, we know y is 1. So we can find the equation now. Any questions? Any questions there? I know all the writing. Any questions? I'm just going to use the formula now, right? Y minus y1 is equal to m by x minus x1. So that's y minus 1 is equal to 18 by x minus 2. Multiply it out, you'll get y is equal to 18x minus 36 plus 1, which is 18x minus 35. 18x minus 35.